A container in the shape of an open rectangular box has a base that is twice as long as it is wide. It is required for the volume to be 5,000 cubic centimeters. Find the dimensions that minimize the material used. So, we are going to have an open rectangular box. So something like this. And if we say that this is x, then we know it has to be twice as long as that. So this would be 2x. And let's just call the height y. Now remember, this has no top. The volume would be 2x times x times y. And so that is going to be 2x squared y. But we know the volume has to be 5,000. So that gives me 2x squared y is equal to 5,000. And therefore y would be 5,000 over 2x squared, or 2,500 over x squared. Now, the surface area of material used, so we've got this front face here, which is going to be 2xy. And we'll have two of those because there's going to be one of those at the back over here as well. And then we're going to have an xy and another xy. And then we'll have the base, which will be 2x squared. So that is going to be altogether 6xy plus 2x squared, which is 6x, 2,500 over x squared plus 2x squared, which simplifies to 15,000 over x, or x to the negative 1, plus 2x squared. Now we want to minimize the surface area. So ds dx is going to be negative 15,000 x to the negative 2 plus 4x. So that is negative 15,000 over x squared plus 4x. And we want that to be equal to 0. So that will give me 4x is equal to 15,000 over x squared, which gives me x cubed is 3,750. And therefore x would be the cube root of 3,750, which will give me 15.54. And that would be in centimeters, correct to 2 decimal places there. So we have that the length would be double that. So that's going to be 31.07. The width is the 15.54. And for the height, we can go back and use this. And that is going to be 10.36 centimeters.